Okay. And I used to skip this page, but I think it's important to do it because you guys, we just need to keep talking about how to do transformation because the problem 4 said you didn't get it. So, well, you may not have understood. A lot of people don't understand that the other part of the question too. But okay, so here's some common graphs of rational functions. This is 1 over x. And if you're going to graph these functions, these are the points you want to use. These are the easy points. Here's some easy points for 1 over x squared. So we're going to use the graph of 1 over x. We're going to use transformations to graph this function, g of x. So first we're going to draw our f of x in this first graph equals 1 over x. So it's drawn up there. It has a point at 1, 1. It has a point at 2, 1/2. And it also has a point here. And it's like that. It has a vertical asymptote at x equals 0. It has a horizontal asymptote. I'll mark it over here. HA at y equals 0. Because what's the degree of the numerator here? This will be 1x to the 0. It has 0 degree. The denominator is x to the 1. M equals 1. So n is less than m. So we have HA at y equals 0. That's a little harder. X. If you have a constant term, the degree of a constant term is 0 because you could put x to the 0 there. So anyway, here's our function, and here's the other side. It has a -1, -1, a line here, there. There's our original function. So let's see. Because our original function is 1 over x, when we're adding 2 in the denominator, this is inside the function. It changes x. And because we're adding 2, we shift left 2. So we can subtract, we could subtract 2 from each x coordinate. So if you're going to do it with points, I'll just pick some points, say -1, -1 on this one. That we're going to subtract 2, -1 -2 is -3, -1. And so we're going to be here. Or you could see, if you start here and go over 1, 2, you will be here. What happens to the vertical asymptote as you shift left 2? Let's draw the horizontal asymptote. We subtract 2 from x equals 0. Vertical asymptote. So, I don't know. If you want to see the points, we subtract 2, you get -1, 1, 0, 1/2. So, -1, 1, 0, 1/2. But we really need to draw that horizontal the vertical asymptote. Our vertical asymptote, because it shifts left 2, so it's at x equals 2, negative 2, I mean. We have to draw that. It's really going to help you to draw the asymptotes first. Negative 2. That's at 8, the VA at x equal negative 2. Here's the graph. Remember, it can't cross its vertical asymptote. This is step 1. You shifted left 2. So you can do the points if you want. You definitely need to shift your vertical asymptote. What happens with the horizontal asymptote when we shift left? It stays right here at y equals 0. The horizontal asymptote stays at y equals 0 when we shift left or right. Alright, the second step is that we're subtracting 1 on the outside. So on the outside, it changes y. And it's a shift in the direction you would think. It's a shift down 1 unit. So let's draw our asymptotes first. What happens to the vertical asymptote when we shift down 1 unit? It stays in the same place. So we still have a VA at x equals negative 2. What happens to the horizontal asymptote when we shift down 1 unit? It shifts down 1 unit. So we have a horizontal asymptote at y equals negative 1. So we draw our asymptotes first, shift those. Now, if you want to shift, this is subtract, the shift down 1 is subtract 1 from each y coordinate. So for this point, it's now going to be minus 3, x stays the same, minus 2, minus 1 is minus 2, x stays the same, 1 minus 1 is 0, x stays the same, 1/2 minus 1 is negative 1/2. You can either use those points or realize, here's where my asymptotes cross. I'll have a point here, which I did, and I'm going to have a point here and here for this graph, here, here, and here. You're going to have a point right here, and I did find that, minus 3, minus 2. And we've shifted our graph. This is g of x. Okay, so inside the function, because it's a 1 over x function, it's going to be when we're adding or subtracting something to in the denominator with that x. Outside the function is out here. So if you can recognize inside and outside, that helps on these transformations. And they all work the same way. If it's a change on the inside, it changes x, but changes it in the opposite direction, you would think. If it's on the outside, it changes y, it in the way you would think. Okay, any questions? Is that, we've been doing transformations all semester, so it's important. But that's the transformation. All right, we have 2 more pages. Now we're going to put it all together and graph these things. So the 2 pages are 2 big examples of graphing. That's what we got, right? Yep, 2 big graphs. Now, on the test, I don't make you memorize these steps. I actually ask you the steps. And usually this step doesn't help you a lot, but it can. We'll go over it. But finding the y-intercept, finding the x-intercepts, finding the asymptotes, and then you can use your calculator and table feature to help you and sketch the graph. The most important thing is to get the vertical asymptotes and the horizontal asymptotes drawn in with dashed lines on these. So we're going to do this, and it's going to, but your test problem will be more like your homework, 2.6 homework, where it tells you to do all these steps. It gives you the steps. It's the second page there. It gives you the steps, and then you're going to graph it. It's not just saying graph this and doesn't give you any steps. So at least it's giving you the steps. All right, so we're going to look. We're going to determine whether the graph of f has symmetry. So, number 1, and this is the definition of even symmetry, and this is the definition of odd. So if we want to check symmetry, first we're going to check if it's even. We're going to find f of minus x. And if it equals the original function, then it's even, and we can stop. So everywhere you have an x, you're going to replace it with minus x. So minus x times itself 4 times. That's what this means. If you multiply negative signs together, if you have an even number of negative signs, each 2 negative signs cancel each other out. You're going to get a positive here. If you have 4 negative signs, you're going to get a positive. You don't have to write the plus sign. And then you have x. It's all, you know, you have x to the first power. X times x times x times x is how many x's multiplied together is 4. So the top of this simplifies to x to the 4th. Minus x squared would be just 2 of these. 2 negative signs cancel, and x times x is x squared. So that simplifies to x squared. And what do you know? This equals our original function. So this does help us in this problem. It is an even function. And so it has y-axis symmetry. Step 2, find the y-intercept. To find the y-intercept, you set x to 0 and solve for y. So in function notation, to set x to 0 is this. Your f of 0. You're finding f of 0. So that's 0 to the 4th divided by 0 squared plus 1. 0 times 0 times 0 times 0 is 0, and 0 plus 1 is 1. So that just gives us 0. So the y-intercept is 0, 0. I want you to write it as an ordered pair. And that's not that helpful. But so number 3, let's find the x-intercept. Now let's look back at the directions. Remember, we have a rational function, and we said that it was p of x over q of x, where these were polynomial functions. So actually your x-intercepts can be found by solving the equation p of x equal to 0. The numerator, you can just set the numerator to 0. Well, usually we set f of x to 0. But what happens if we set f of x to 0? We can multiply through by q of x and it's just gone. Do you need me to? So x-intercepts, if you can remember to set the numerator to 0, that saves some steps to find the x-intercepts. The reason, when you're on the x-axis, y is 0, but we're using function notation, so actually you set f of x to 0. Let me show you that if you can't remember to set the numerator to 0, if you set all of f of x to 0, you can actually multiply through by the denominator and that actually cancels out. Oh, and 0 times anything is 0. That's why I'm crossing it out. 0 times anything is 0. So you actually get x to the 4th equals 0, or you get the numerator equals 0. So setting the numerator to 0 is just a shortcut for finding your x-intercepts. If you can remember that, for a problem, do that. It's a shortcut. But you can multiply through by the denominator. If you set all of f of x to 0, you get rid of the denominator, and you are only setting the numerator to 0. So if you can't remember to set the numerator to 0, but if you can remember that, you can multiply through and get rid of the denominator on that. But that's why you set just the numerator to 0. Is that clear as mud? Okay. Well, if you set x to the 4th to 0, that means that x equals 0. And so our x-intercept is not helpful. It's 0, 0. Okay. All right. Step 4, find any vertical asymptotes. We want to find our VAs. So we're going to write our f of x here again to remember what it is. X to the 4th over x squared plus 1. So does this factor? Does x squared plus 1 factor?
Yeah.
What'd you say?
Yeah.
You're right! It doesn't factor! All right! She's got it! So, because and it doesn't factor, and can it ever be 0? You got it! So guess what? There are no VAs. That's your answer. Because x squared plus 1. If you set it to 0, you subtract the 1. X squared equals a negative 1. You can't ever get a real number equal to, if you can't square a real number and get a negative. So there are no BAs. Number 5, find any horizontal asymptotes. HAs. Okay. Horizontal asymptotes. So, what's the degree of the numerator? 4. What's the degree of the denominator? 2. And so n is greater than m. So what does our rule say? N greater than m. There's no horizontal asymptote. It's not helpful, but this is the answer. Okay? So there are no horizontal asymptotes. So we write no HAs, and we box it in because we're sure of that. Step 6, we're going to use our calculator. So y1 equals x to the 4th divided by parentheses x squared plus 1. And you do need those parentheses. Okay, so we're going to use the calculator. Y equals, clear it out, x caret 4 divided by parentheses x squared plus 1. But we're gonna, do I need to, is my table set up okay? Yeah. Okay, second table. We're gonna use the table feature and find some points. Okay. Alright, well, what do we have so far? We have that it's an even function. Wow, we have 1 point on this graph so far. We have this point, 0, 0, and we know it's even. So we better find some points to the right of 0. So let's just find at 1, at 2, and at 3. So we're going to look in our calculator. At 1, it's at a half. At 2, it is at 3.2. And at 3, it's at 8.1. And it's symmetric. So, and you can see at negative 3, it's at 8.1. At negative 2, it's at 3.2. And you can see that right there. You can see the point 0, 0. So, here's the graph. We're going to graph that now. 1.5 minus 1.5. 2, 3.2. Negative 2, 3.2. And 3, 8.1. There we go. And it looks like a parabola. And there's our graph. So there were no asymptotes. Okay. We'll do the last graph if you're done writing, drawing. Got it? So this last graph is more like what your worksheet is. Okay. Okay. All right, so number one, we're going to check symmetry. So find f of minus x. That's 4 minus x squared over minus x squared minus 9. And that is 4x squared over x squared minus 9. And that equals f of x. So it's even. And you can stop. Maybe I should just show you if you had to check for odd, you can stop. I'm just saying to check for odd. Here's the thing, you want to find minus f of x and see if it equals that. It won't, because it can't be both even and odd. But when we're finding, we have a p of x over q of x. Remember, if we have a minus sign in front of a fraction, we don't put two minus signs. Everybody does this. You just put it on the numerator. So if we were going to find the opposite of f of x, it would, for this problem, it would simply be negative 4x squared over x squared minus 9. If you make this negative 2, you've just done a negative divided by a negative, which is a positive. And you didn't change the sign, the negative at all. Of course, this does not equal that, so it's not odd. We could have stopped, you know. Just want to do that. When you're checking for odd, only change the sign on the numerator. So we'll write that down. Only, this is a common mistake. If you change the sign on both, it's a double negative, and it's just the positive. Okay. All right, but we checked symmetry. Now we're going to see the y-intercept. For the y-intercept, we want to set x to 0. That's f of 0 is 4 times 0 squared over 0 squared minus 9. Everywhere we have an x, we replace it with 0. You get 0 over negative 9 is 0. So the y-intercept is 0, 0. This is kind of, am I doing the right one? Yeah. Yep. Yeah, okay, so the next one, finding the x-intercept. It's easiest, if you can remember, is set the numerator equal to 0. It's just going to be easier if you can remember that for rational functions. So 4x squared equals 0. And you can divide the 4 out. X squared equals 0 means x equals 0. And so the x-intercept is 0, 0. Okay, now we're going to find our VAs. So we want to set the simplified denominator equal to 0. So let's first simplify our function if it simplifies. Now this is a difference of perfect squares. it's going to be two binomials. The first term, to get x squared, you're going to do x times x. The last term has to be negative, and it's 3 times 3. So one's positive and one's negative. If you FOIL that out, you're going to see you get x squared minus 9. So nothing cancels, so this is the simplified denominator. X plus 3 times x minus 3 equals 0. So x equals negative 3, or x equals 3. So we have VAs at x equals negative 3 and x equals 3. And we'll draw those in a minute. 5, horizontal asymptotes. So we have our function right here. What's the degree of the numerator? 2. What's the degree of the denominator? 2. Brianna knows that. And you guys are getting this. So n equals m. So we follow the rules that are given on our formula sheet. I already know what the rule is, but show you again. You are just following these rules. Degree of the numerator equals the degree of the denominator. So the line y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator is the horizontal asymptote. So it's y equals, you could even write y equals a sub n over b sub n. Let's look at, here it is, the leading coefficient of the numerator is 4. The leading coefficient is an understood 1 of the denominator. So the line y equals 4 is a horizontal asymptote. Okay, so we've got vertical asymptotes, we've got horizontal asymptotes. We've got that it's even, and we've got an intercept. So let's just go ahead and draw that part first. When you make a graph, did you finish copying all that, guys? When you make a graph for me of these things, you're required to draw the horizontal and vertical asymptotes. So the horizontal line y equals 4 is right here. And we label it HA at y equals 4. Now we do know that the point 0, 0 is on the graph, so there it is. Okay, let's draw our vertical asymptotes. We got one at negative 3. And we want to label that as VA at x equals negative 3. And the other one's at positive 3. X equals positive 3. So VA at x equals positive 3. Okay, now that we got that part labeled, we're going to use our calculator. And we need to find some points. These vertical asymptotes break up our number line into 3 sections. This one, and this one. We need to find points in all 3 sections to graph this. So we're going to use the calculator. So I want to find, so I'm going to put in y1 equals 4x squared divided by x squared minus 9. I'm going to make 3 tables of values just to show you. I want a table for this area, a table for this area, and a table for this area. Or, oh wait a minute, it's symmetric. We could use the symmetry and only do half of that and reflect it, or do this half and reflect it. But I'm just going to show you, suppose it wasn't symmetrical, which your homework's not. So let's just find some points. Let's find -6, -5, and -4. Those are 3 points that will be in this area. And then for the middle part, we're going to find -2, -1. We already have 0. We don't need that. 1 and 2. And because it's symmetrical, we wouldn't need all these points. But in the right half, but your graph that you have to do on your homework is not symmetrical, so you'll have to, I don't think it is. Remember. 6. We want to do 4, 5, and 6. 4, 5, 6. So let's put this in our calculator. Turn it on. Second quit. Y equals. Clear it out. If you want, you can put the numerator in parentheses, but because it's just one term, I don't need those. I'll go ahead and write it like that so you can see. If you're not sure, it doesn't hurt to put the numerator in parentheses. Divided by the denominator in parentheses. X squared minus 9. Now we're going to do second table. And we're going to go down to -6. So at -6, and we're only going to be really, I'm just going to write 1 decimal place because we can't really graph any further than that. 5.3. At -5 is at 6.3. At -4 is at 9.1. At -2 it's at -3.2. At -1 it's at -0.5. And you can see that it is symmetrical. At 1 it's at -0.5 again. And at +2 it's going to be at -3.2. And at the asymptotes you'll get errors. Okay. At 4 it's at 9.1. At 5 it's at 6.3. And at 6 it's at 5.3. So we do have to get points in all 3 sections that the vertical asymptotes break it up. And now we're going to graph that. At -6 we're at 5.3. At -5 we're at 6.3. At -4 we're at 9.1. You can also hit graph to see what it looks like, but I'm drawing this. -2, it's at -3.2. At -1, it's at -0.5. At 1, it's at -0.5. At 2, it's at -3.2. And then at 4, it's at 9.1. At 5, it's at 6.3. At 6, it's at 5.3. Alright, and that's the graph. Everything's labeled. We can look in our calculator. We can press graph on our calculator Here's what it looks like on the calculator. Okay. But you don't draw those lines. On the asymptote, the calculator tends to draw those lines. It depends on your calculator. The newer ones may not do that. Or you can go to mode and you can make it be in dot mode. Here's what it looks like in dot mode on mine. Yeah, and that looks a little better.
It's sad.
It's very.
It's a sad face.
Oh, it is a sad face. Yes. Oh. Okay. So that's how you do the second page of your worksheet. That's due. And we're done. If you have questions.